Welcome to Your Space Journey, where we venture into the future of space exploration. Your journey begins now.
Welcome back to Your Space Journey. We'll really dive in deep today with some news from the James Webb Space Telescope. It's pretty wild, actually, what they're finding out about how fast the universe is expanding. It's kind of blowing my mind, to be honest.
Yeah, it's definitely shaking things up in the world of astrophysics. So the James Webb, or JWST as it's known, it's giving us like the most accurate measurements ever of the Hubble constant, which basically tells us, how fast the universe is expanding. And what it's finding, well, let's just say it's throwing a wrench into some of our most fundamental theories.
Okay, so can we back up for just a sec? I definitely remember learning about the Hubble constant, but it's been a while. So what exactly is it again? And why is it so important?
Right. So you can think of the universe like a giant loaf of raisin bread. It's baking in the oven, and as the bread rises, the raisins, which are like galaxies, move further and further apart. And the Hubble constant, that's essentially the speed at which those raisins are moving away from each other. It's measuring how quickly the fabric of space itself is expanding.
Oh, yeah. Okay, the expanding universe, I remember now. So this wrench that the JWST is throwing into things, is it just that the universe is expanding faster than we thought? Or is there something more to it?
That's the basic idea, yeah, but the implications are huge. The measurements we're getting from the JWST, they're showing an expansion rate that's way faster than what our current models predict. And this discrepancy, we call it the Hubble tension. For years, scientists thought it might just be a measurement error, but the JWST is so precise, it's basically confirmed that the tension is real.
So does that mean, like, our best theories about the universe, are they just wrong?
Well, it's not quite that simple. The standard model of cosmology, the one that describes the universe's composition and evolution, it's been incredibly successful in explaining a lot of what we observe. But this Hubble tension, it suggests that we're missing something. Like, there's an ingredient in the cosmic recipe that we haven't accounted for yet.
Okay, now I'm really intrigued. What could this missing ingredient be?
That's the big question, isn't it? One of the leading contenders, though, is something called early dark energy.
Early dark energy. Is that different from, like, regular dark energy?
Think of it this way. Dark energy is this mysterious force. We think it's driving the accelerated expansion of the universe. We don't know much about it, but we can observe its effects. Now imagine there was a form of dark energy that was way more powerful in the early universe. Right after the Big Bang, this early dark energy could have given the universe this extra kick, making it expand faster than our current models predict. And as the universe aged, this early dark energy would have faded away, leaving behind the dark energy we observe today.
So it's like the universe had a growth spurt early on.
Yeah, exactly. And while that's one of the leading explanations, there are other possibilities too. Some scientists think maybe our understanding of gravity needs some tweaking. Or maybe there are these exotic particles we haven't discovered yet that are influencing the expansion rate.
Wow, okay. So this Hubble tension, it's not just a headache for cosmologists. It sounds like it's a huge opportunity to make some groundbreaking discoveries about the universe.
Absolutely. It reminds us that science is a process of constant refinement. We observe, we theorize, and when we find these discrepancies, it pushes us to think outside the box and maybe even rewrite the textbooks.
And speaking of pushing boundaries, the JWST has been just blowing everyone away with its images and data. Can you tell us a little more about how it's helping us understand this Hubble tension?
The JWST is a total game changer. It can see further back in time and with way more clarity than any telescope before it. It observes an infrared light which lets it peer through dust and gas, the stuff that usually obscures our view of the early universe. And because the speed of light is finite, looking further away is basically like looking back in time. The JWST is allowing us to study some of the earliest galaxies ever formed, which is super crucial for understanding how the universe has evolved over billions of years.
So the JWST is like a time machine. It's giving us a glimpse into the universe's baby pictures. And by studying those early galaxies, we can get a better idea of how fast the universe was expanding back then and how that expansion has changed over time. That's incredible.
It really is. And the data from the JWST is just starting to pour in. It's a really exciting time to be a cosmologist, because we're on the verge of some major breakthroughs in our understanding of the universe and its evolution.
I'm already hooked. Can't wait to see what the JWST reveals next. But before we dive into the specifics of how the JWST is helping us unravel the Hubble tension, let's take a quick break. We'll be back in a moment to continue our exploration of this cosmic mystery.
Sounds good.
If you're enjoying this interview, be sure to subscribe. Thanks for listening.
All right, so we know the JWST is giving us this incredibly detailed look at the early universe. How exactly is that helping us with this whole Hubble tension thing?
Well, it's all about using what they call standard candles, right? Astronomers use certain types of stars and supernovae to measure distances across the universe.
Yeah, you got it. One of the main ways we measure the Hubble constant is using these standard candles. And these are objects that have a known intrinsic brightness, meaning we know how much light they actually give off. And by comparing their intrinsic brightness to how bright they look to us here on Earth, we can calculate their distance. It's kind of like if you know the wattage of a light bulb, you can then figure out how far away it is based on how dim it appears.
Oh, I see. So the dimmer the light bulb, the farther away it is.
Exactly. And certain types of supernovae, which are these exploding stars, they make really good standard candles because they give off a very predictable amount of light. And the JWST, with its amazing sensitivity, it can detect these supernovae in incredibly distant galaxies, which means we can measure distances across huge stretches of space.
And knowing those distances is key to figuring out the expansion rate right.
Exactly, by combining those distance measurements with measurements of the redshift of galaxies, which tells us how fast they're moving away from us. We can calculate the Hubble constant, and the more accurate our distance measurements are, the more accurate our Hubble constant calculation will be.
So the JWST is basically giving us a much more accurate ruler to measure the universe with.
Yeah.
And those measurements point to this faster expansion rate, the Hubble tension.
Right, and that's what we're trying to figure out. It's not just about getting better measurements, though. It's about what this discrepancy tells us about the universe itself. Does it mean we need to rethink gravity? Are there new particles or forces we haven't discovered yet? Or is it something else entirely?
This is where it gets really mind-blowing. The possibility of new physics at play. That's just incredible.
It really is, this Hubble tension. It's pushing us to the edge of what we know. It's like we've been putting together this giant jigsaw puzzle of the universe, and suddenly we found some pieces that don't quite fit. Now we need to figure out if we're putting it together wrong, or if there are missing pieces out there.
And those missing pieces could lead to entirely new areas of physics and cosmology. What are some of the most promising research areas that scientists are looking into to try and explain this tension?
Well, like we talked about earlier, the idea of early dark energy is getting a lot of attention. If there was a type of dark energy that was dominant in the early universe and then faded away, it could explain why we see this faster expansion rate.
But how can we even look for something that existed billions of years ago?
It's a tough one, but there are ways. One way is to study the cosmic microwave background radiation. That's like the afterglow of the Big Bang. Tiny variations in this radiation can tell us about the conditions in the very early universe, including maybe the presence of early dark energy.
So it's like searching for fingerprints in the cosmic radiation, looking for traces of this early dark energy.
Exactly. And the JWST is going to be a big help with this. It can see the early universe in such incredible detail. Another way is to look for small variations in the distribution of matter throughout the universe. If this early dark energy was around, it would have left some kind of mark on the structure of the cosmos.
So it's a multi-pronged approach, using different telescopes and instruments to try and solve the Hubble tension. And it sounds like, even though it's a difficult problem, there's a lot of optimism that we'll eventually figure it out.
Yeah, there is. The Hubble tension has brought a lot of excitement back into cosmology. It's pushing us to be more innovative and work together. And there's a whole new generation of scientists coming up who are eager to push the boundaries of what we know.
It really does feel like we're on the edge of a whole new era of cosmic discovery. But all this talk about the Hubble tension, what does it all mean for us here on Earth? How does it affect our everyday lives?
That's a great question. You might think that the expansion rate of the universe is only important to scientists, but it actually touches on some really fundamental questions about our place in the cosmos.
Okay, I'm listening.
Well, for starters, the expansion rate is directly related to the age of the universe. If the universe is expanding faster than we thought, it could mean that it's actually younger than we previously calculated. And that changes how we understand the evolution of stars, galaxies, and ultimately even life itself.
So a faster expansion rate could mean a younger universe.
Yeah.
And that could change our whole understanding of the timeline of cosmic events.
Exactly, and it goes beyond just the age. The Hubble tension also affects how we estimate the amount of dark matter and dark energy in the universe. These are the mysterious things that make up most of the universe's mass and energy, and they have a huge influence on how cosmic structures evolve.
So if we don't have the expansion rate right, our understanding of the universe's composition, the balance of dark matter and dark energy, that could be off too.
That's right. And that has big implications for how we think the universe will evolve in the future. Will it keep expanding forever? Will it eventually collapse back in on itself? Or will something completely different happen? These are all questions that are connected to the Hubble tension and our quest to understand the very nature of the universe.
It's amazing to think that something as abstract as the expansion rate of the universe could have such a big impact on how we understand everything, our place in the cosmos, the whole shebang.
It really is. It's a great example of how interconnected science is. Discoveries in one area can have these ripple effects across all sorts of disciplines, leading to unexpected connections and insights.
This has been a fascinating journey, and I'm really excited to see what the future holds for our understanding of the Hubble tension. But before we wrap up, there's one more thing I've been wondering about.
Let that.
We've talked a lot about the science of it all, but what about the human side of things? What's it been like for scientists to be faced with this challenge? Has it been frustrating, exhilarating, a little bit of both?
It's definitely been a mix of emotions. I mean, there's definitely some frustration. Our current models don't quite match up with what we're seeing. Scientists spend years, sometimes decades, building and refining these models. It can be tough to have those models challenged in such a fundamental way.
Yeah, I can imagine. It's like having your whole belief system shaken up.
Exactly. But at the same time, there's also this incredible sense of excitement and opportunity. The Hubble tension is telling us that we're on the verge of a major breakthrough. It's forcing us to be more creative, to think outside the box. And that's what makes science so rewarding.
It's that thrill of the unknown, the possibility of discovering something truly groundbreaking, something that could change our entire understanding of the universe.
Exactly. The Hubble tension is a perfect example of how science works. We observe, we theorize, we test, and sometimes we have to go back and revise our theories, sometimes even completely overhaul them. It's a constant process of learning and refining.
And it's driven by human curiosity, our ingenuity, and this deep desire to understand our place in the cosmos. This has been an incredible deep dive into the Hubble tension, and I'm really eager to see what the future holds.
Me too. And one thing's for sure, this journey is far from over. The JWST and all these other amazing missions coming up, they're going to revolutionize how we understand the universe. And the Hubble tension is a big part of why.
It's a great reminder that the universe is full of surprises, and our quest to understand it all is nowhere near finished. Before we get too carried away, though, let's take a minute to go over what we've learned today about the Hubble tension and what it all means.
Okay, sounds good. Let's do a recap.
So we've spent all this time talking about the Hubble tension. The universe is expanding faster than we thought. What are the big things you want our listeners to remember?
Well, the main takeaway, I think, is that the JWST is really delivering. It's not just about the amazing images. The data it's sending back is so precise, it's making us rethink some really fundamental things about the universe. The Hubble tension is definitely a real thing. It's not going away anytime soon. And honestly, that's a good thing. It means there's still so much about the universe that we don't understand.
Yeah, it's like we thought we had it all figured out. And now the universe is saying, think again. So where do we go from here?
We keep exploring, of course. The JWST is still early in its mission. It's going to be gathering data for years to come. And it's not the only one. There are other telescopes, both in space and here on Earth, that are helping us solve this cosmic mystery.
Right, it's a team effort. I read that there's a new telescope called Euclid that's launching soon. What's its role in all of this?
Oh, Euclid is going to be huge. It's going to create this incredible 3D map of the universe, covering billions of galaxies. It'll give us so much information about dark matter and how cosmic structures have evolved over time. That data is going to be essential for testing different models of dark energy, and hopefully it'll shed some light on the Hubble tension.
A 3D map of the universe. That's just mind-blowing. It really feels like we're in a golden age of cosmology.
I think we are. We have these incredible tools, and we're making groundbreaking discoveries. And it's not just about the technology. It's about the amazing people all over the world who are collaborating and pushing the limits of what we know. This Hubble tension has really sparked a fire in the scientific community, and I'm confident we'll make some serious progress in the years to come.
This has been such a fascinating deep dive. I feel like I have a whole new understanding of how vast and complex the universe is, and the incredible work that scientists are doing to unravel its secrets.
I'm glad to hear that. And remember, this is just the beginning. The Hubble tension is just one of many mysteries out there, and every discovery we make opens up new paths to explore.
It's like peeling back the layers of a cosmic onion, and every layer is even more fascinating than the last. Thanks for joining us on this deep dive into the Hubble tension. We hope you'll keep exploring the universe with us here on your space journey.
Your space journey.